Okay, so here's part two, the part where we're kind of describing things that we see in the real world and using Newton's three different laws to try to kind of make sense of why the things are doing what they're doing. Why do we wear a seatbelt in the car? It's the same real reason why when I made toast this morning, the toast was on the plate, and when I walked away from the toaster and I moved the plate whichever way I moved it, the toast just stayed put. The toast wasn't moving before I took off, and the toast wasn't moving after I took off. So the object stayed at rest, like Newton's first law said. There wasn't enough friction with the plate to bring it along with the plate. The friction would have been an unbalanced force that would let it be pushed forward to accelerate with the plate. And the first law says if there's no unbalanced force, there will be no acceleration. Riding the skateboard. So if we're on the skateboard, we're rolling along, could be roller skates, whatever, could be a bike. My wife ran a bike into a curb and went flying over the handlebars when we were dating 25 years ago. And I said, well, how could you do that? And of course, that was the wrong thing to say when she was laying on the ground. So don't do that, guys. But if you hit something and it makes your skateboard stop and you are moving with a velocity, well, you're going to keep moving, and that's the other half of Newton's first law. So if you're in motion, you're going to stay in motion again unless you have an unbalanced force. So on you, there's no unbalanced force. On the skateboard there is, so it stops, but on you there's not. And so that is still Newton's first law. So first law. So N1L, Newton's first law. I think you've seen N2L enough times, and hopefully N1L for Newton's first law enough times to know what I mean when I abbreviate it that way. So now, in a canoe, I don't know if you've ever done this before, but it's been a close call for me before. So I'm going to change colors, and I got to do the little eraser thing for some reason before I can change colors, or it'll do that. So why didn't it do that? Now I can change colors. Let's go purple. So we're in the canoe. So this is the front view of the canoe, and this is you trying to step off from the canoe, and the dock is over here. You can applaud my artistic skills at another time. But if you're trying to step off onto the dock, your foot, you push with your foot that way. You're expecting the canoe to push you forward and get you to the dock. So that would be a Newton's third law kind of a thing. You push on the canoe should push you back. That's what happens when you're on solid ground and you move forward. However, this is going to change everything. And then I can do this, and then I can change it to something else, which is what I wanted to do. So, okay. Now I can write in different color. So that was Newton's third law. Newton's first law says that you were at rest. So just like in the toast example, Newton's first law says you are at rest. Well, until you get a force that pushes you forward, you're going to stay at rest. And so that's why you might drop into the water. What you are hoping for is Newton's second law, as it says that the canoe should provide a force that's not It's not canceled out by anything else on you. So you're hoping that it pushes your foot forward and your body forward, like when you're pushing off on the ground to move forward. So pushes your foot forward, FW. You're hoping for that. But because there's really no friction between the water and the canoe, that doesn't happen. So because you don't get that friction force with the canoe moves away from you. Because you don't get that force from the canoe, it doesn't push you forward. And because you're at rest relative to the water in the dock, you're going to kick the boat out from under you and you're going to drop straight down like the toast did. So Newton's first law, Newton's third law, Newton's second law can all be applied to this in one way or another. Sorry about the cough. Hopefully I got that cleared up. Number 4. Provide examples that you understand the relationship between net force, mass, and acceleration. So if you remember in the quiz review, I put out there that if we rearrange Newton's second law to be this, so if we just rearrange it from F equals ma and divide by m to solve it for a, then the bigger the mass, the smaller this fraction would turn out to be. So there's a reciprocal relationship. Reciprocal and inversely proportional are the same thing. Reciprocal from a math perspective. So what does this mean? If we double the mass, 2 times the mass, we'd get 1/2 the acceleration. So remember on the quiz when I stacked a second identical car on top of the first car, that doubles the mass, it would chop the acceleration in half unless somehow the motor got more powerful. If we make the mass 5 times bigger, so if you stack up 5 cars on top of each other and you can still drive the bottom one, you would only get 1/5 as much acceleration as you would before you changed anything. So that's the reciprocal. Reciprocal is the same thing as inverse in math land. And so then the relationship between the net force and the acceleration is way easier. The harder you push something, the bigger you can make its acceleration. So these are proportional. So A is just directly proportional to F net. What does that mean? That means if we make our unbalanced force, the net force, 3 times bigger, then we're going to get 3 times the acceleration. Make it 10 times bigger, you get 10 times more acceleration. So that's pretty straightforward. And if you just remember heavier things are harder to get moving, then that's your inversely proportional idea. If it's twice as heavy, it's twice as hard to move, so you're only going to get 1/2 as big of an acceleration. The last thing, mass and weight. Mass is how much stuff is in an object, how many molecules, how many atoms make up an object. But weight and force of gravity are this mg thing, and remember that g is 10 newtons worth of force for every kilogram in an object. So 10 goes in and we multiply our mass by 10, and that gives us our force of gravity. Don't forget, force of gravity is just the scientific name for weight. So if I ask you how much a 2,000 kilogram car weighs, it's 2,000 kilograms times 10. So it'd be 20,000 newtons in the weight system. So hopefully that helps you get ready. And if you have questions, let me know.